Good morning, ladies and gentlemen. Today we're going to look at combining linear and geometric patterns. This is a feature we look at again and again throughout finance because this is how we model effectively loans like mortgages and car loans. However, they can also be used to model other more interesting scenarios in real life. So let's take a real life example now. A population of 1,200 elephants increases by 4% per year, but 400 each year. So let's use a recurrence relation to model this and then see what happens over the first 4 years. So the initial number of elephants, and remember we can use any really, so let's say the initial population is 1,200. And then from 1 year to the next, we get the next year's population by doing 1.04 times the previous year's population, then we subtract 400. Now note that 1.04 is what's increasing by 4%. If you're struggling, use the 1 plus r on 100 to increase, and 1 take r on 100 to decrease. Alright, so PO is 1,200. What would after the first year be? Well, after the first year, we're taking 1,200, increasing it by 4%. So 1,200 times 1.04, and then subtracting 400 off the end. There is 848. And again, we take that, multiply it by 1.04, subtract 400. So then P2 is equal to 1.04 times 848, take 400, is equal to 481.9. Really, you can't have 0.9 of an elephant. So because we haven't got a whole elephant, we'd round down to 481. Then P3. Same thing again. .19, so just 101. P4 is going to be negative. So instead of writing negative, which makes no sense, then we'd say there's no elephants left. Unhappy face. All right. In general, the way we model it is we have a starting value, and the recurrence relation looks like this. R is used to both note how it's always times for both growth and decay, we always multiply, and then plus or minus a common difference. So in a financial setting, we would get a, sorry, not even a financial setting yet. Finance is next lesson, another real life one. All right. Each day, 1.5% of the water in a swimming pool is lost due to evaporation. At the end of each day, 1,000 litres of water is added to the pool. The pool starts with 150 litres. Use a recurrence model to model this relation. Alright, well, clearly we're going to start off with VO, volume, initial volume of the pool, is 150,000, comma. The final volume is not the final volume, to get from one to the next, because we want the next part of the recurrence relation, we're going to decrease it by 1.5%. Now, decreasing by 1.5%, you can do by saying 1 take 1.5 on 100, and that will, if you put that in your calculator, will go 0.985. So that's what we want to multiply by to decrease it by 1.5%. So we would multiply by 0.985 Vn, adding into the water 1,000. Alright, now how many litres in the pool after 5 days? Because it doesn't tell us to do it by hand, let's do it on the calculator. Now, one way to do it on the calculator is this. We're starting with 150,000, and then to get from one line to the next, we do 0.985 times A1 plus 1,000. And we drag it down. And we can see for the first 5 periods, first 5 days, that's what happens. It slowly dips. Let me show you another way we could generate this. It's called sequence generator, and it's worth writing these commands down. Menu, data, generate a sequence. Now, generate a sequence is perhaps an even quicker way of filling in a whole data set like before. You don't have to worry about trying to drag it down. Now the formula is always in terms of UN. So we have to look here at UN, and then this is actually a recurrence relation here. But to get to UN, we need to do something to the previous one. The previous one in this case is UN take 1. So to model our recurrence relation here, we'll do 0.985 times U bracket N take 1. Then we would add in 1,000. All right. Initial term, it says initial terms because you can have 2 of them, but not in VCE, is 150,000. Now, NO, we're going to start at number 1 and step through to a maximum of 255 steps. So let's see what that looks like here. Click OK. And you can see we've generated exactly the same sequence as over here, and it goes down 255 times. All right. Now, let's have a look. How many liters in the pool after 5 days? Well, after 5 days, we're going to be 6. We would write down this number here. Ooh, should be that one there. So 1439934. How many days will it take for the pool to reach 130,000? Well, here we could continue scrolling down. So it'll reach 130,000, not at the end of the 20th day, but during the 21st day. Now, how do we do that quickly? Because you can imagine a sequence that can go on for a very long time. You don't want to spend all this time scrolling down. Well, once again, let's go to sequence generator. Data, generate sequence. We want to do 0.985 U bracket N take 1 plus 1,000, starting at 150,000. The ceiling value is the maximum value you're going to reach, so 130,000. Oh, that did not work at all. That's embarrassing. I'm not going to re-record this video. Plan A was good. Scroll down till you reach 130,000. Awkward. Honestly, you won't find a problem where you have to scroll down a ridiculous amount, but I just thought Sequence Generator could do that. If you figure that one out, do let me know. Alright, thank you very much. I won't take up any more of your time. Do put in the notes for how to generate a sequence, please.